into hardwood and softwoods. Okay, so we'll go straight to the last part of it. Now, there's some differences between hardwood and softwood. Hardwood is found in tropical hot regions of the earth, e.g., Africa. We know hardwood is they have broad leaves, e.g., the almond tree or mango tree. They have broader leaves. They have fat, thick, thick trunks. They have they shed their leaves annually. Their seeds are enclosed, and hardwood are best suitable for furniture and for building construction. For softwood can be found in cold regions of the earth. Softwood has slender, thin, long leaves. Example is the palm tree. Another example is um, we also have the Christmas tree, the pine tree, spruce tree. All the ones are under softwood, and we have here the trunk of softwood are usually slimmer and taller. They're used for suitable. They're suitable for furnitures. They're evergreen. Their seeds are also exposed. They also known to have conical shaped seeds. Uh, Conical shaped seed, e.g., like I said before, is the Christmas tree and an example of what of softwood. Okay, so these are just literally some applications of hardwood and softwood, and you might already need to know a little about this, but just need to know some examples of hardwood and softwood so that you can be able to answer some questions on that. We also have here parts of a tree. Uh, a tree has its leaves, it has its branches, it has stem or trunk, fruits, roots, and they all play different parts. We know leaves are responsible for sunlight. They convert the sunlight through the leaves, and in that process, food is generated for the tree. Branches support the leaves, the trunks. Also, you can read about this as you go on. I want you to be fast so that we can actually look at other areas. Then we have this a picture of what the tree, parts of the tree looks like, and you can just look at that to help you understand better. Then finally, we're still going to look at glass, still look at other materials as well. So, structure of a wood. Wood has a very unique structure. It has a sap, the dead bark. The dead bark is the outer part of the tree trunk. It has you have the live bark. Uh, you have the cambium layer, which is directly after the live bark. You have the heartwood, the sapwood, the pith, which is the center of the tree, the growth ring, or sometimes can be also called annual ring. They're responsible for. They tell you how old the tree is. Every year, the tree adds annual rings to tell you how old the tree is. Then we have the medullary. Um, just let me just touch a bit. Bark is the skin of the tree. Cambium layer is the part that produces new cells for the tree to grow. Annual growth is the part of the tree that produces new layer of cells annually. This process forms a concentric ring with the tree, and this phenomenon can help one to determine the age of the tree. The sapwood is the area where water and mineral salts are transported from the root of the tree. Heartwood, this is the most mature part of the tree, and we have the pith to be the center of the tree. Okay, so now we go to metal. We know metal is a solid material obtained from the natural product known as the iron ore underneath the earth crust. Found underneath the earth, you find, and it's a natural product, and they're classified into two major types. You have ferrous and non-ferrous metals. Ferrous metal contain iron content. they also uh, have magnetic properties, which enables them to, because of the iron content in them, they are attracted to any magnet, to magnets. And examples is steel, razor blade, nails, cast iron. All these types are examples of ferrous metals. And we have here non-ferrous metal. Non-ferrous metals do not have contain iron. They cannot be attracted by magnets. Examples include aluminium, copper, and cast iron. So cast iron is supposed to be for non-ferrous metal, not ferrous metal. So steel is a good example of ferrous metal. Razor blades, nails, all these examples of ferrous metal. For alloys of metal, alloys is a mixture of two more metals to produce a new metal. We have ferrous alloys and non-ferrous alloys. When you mix ferrous metals like steel, carbon, tungsten, you have high-speed steel. When you mix non-ferrous alloys like copper, tin iron, you have bronze. You mix copper and zinc, you have brass. All these examples of non-ferrous alloys. Then properties of metal. Metal is heavy, it's dense. That's why it's dense. It has magnetic properties. They can be used as conductors because they can generate. They can be used to transmit electricity and also heat as well. Sound test. They are able to produce sound when they are struck. Brittleness, when they are under heavy weight or pressure, they can break. Ductility means metal can stretch out when heated. That's why you have saggy electric cables. Those high tension wires, they tend to sag after some time. Most of them, those wires, when they're exposed to heat or when current is passing through, they generate a lot of heat, and in that process, their linear expansivity increases, and they begin to sag. Softness, the ability of some metals to resist breaking and cracking. They have malleability, metal can be beaten into desired shape. Hardness, this is the property of metal, not to dent. And possibility means metal can be mixed with other metals in their liquid form to form other products. So that's it about metals. You can go on to read about all these things, and you find them very, very interesting. So we're going to go to the other slides. So we cannot also mention ceramics and glass, and we also talk about plastic and rubber. So under ceramics and glass, ceramic is one of the major raw materials for ceramic is clay, and it's mixed with sand, mud, and cement, and you have stuff like toilets. You have stuff like tiles, floor tiles, wall tiles. You have flower vases, you name it. So basically, ceramics is the major raw material is clay, and cement, sand, but clay is the number one material for making ceramics. So anything can be classified with three groups: refractory ceramics, whiteware ceramics, structural ceramics. For refractory ceramics, they are made from fire clay bricks, and they are used for constructing furnaces, lining, and ovens. While we have whiteware ceramics, which are used for making sanitary ceramics, just like floor tiles, wall tiles, electrical insulators, even toilets, wash and basin. Structural ceramics can be used for making concrete, cement, and these are just some classification of ceramics. So we're going to go to the properties of ceramics. Ceramics has strong property when it comes to heat resistance. That's why you can have hot coffee in a mug and it doesn't break. So it has high heat resistance. It can withstand high temperature, and no wonder it's also used with other composite materials for space shuttles. And we also have that to know that it can be easily decorated. You can easily add colors to it and other things. Brittleness, which means when it falls from your hand, it can easily break. so they can be very, very brittle. Then we have here porosity. It contains pores which evaporation takes place. Air bubbles so as to cool it when cool content, like the pores in clay pots used for water storage in most villages. So high resistance to corrosion. They can be used to store chemicals and water. So you can leave water in a cup mug. It doesn't do anything to it. You try that with metal. For instance, a plastic, a metal cup. You leave water inside. If it's not, even with stainless cup, after some time, it's going to be you find it that's going to be rusting. Then we have also number 6, high compressive strength. High compressive strength. So that's another thing again. So we can see that it's used for tiles, cookware, bricks, toilets, NASA space shuttles, cars, artificial bones and teeth, electronic devices. So those are some things you can use ceramics for. And we then move to glass. Glass is an amorphous, hard, brittle, transparent or transparent supercooled liquid obtained by fusing a mixture of metallic silicates, most commonly sodium, potassium, calcium, and lead. So general properties of glass: glass is transparent, it's very brittle, it softens on heating, it can absorb, reflect, and transmit light. It's a good insulator. It's affected by alkalis, and no definite melting point for glass. It depends on the type and the quality or thickness of the glass, basically. So types of glass include soda lime, potash, lead glass, borosilicate, alumina, silicate glass, optical crop, glass wool, quartz glass, opal glass. Then we move to rubber and plastic. So you might be wondering, can we say rubber can be synthetic? Yeah, rubber has various plastic, which is the most versatile material often used, invented, and has become a versatile material used on a daily basis throughout the world. Plastic materials display unique properties when compared to other materials, and have contributed greatly to quality of our everyday life. Plastics can be natural or synthetic. Natural plastic includes can be from plants, like a rubber tree, and you can get latex from it. Insects, animal horns, and which comes from trees, which is for the latex comes from trees. So animal horns as well, you can also get plastic from there. They also have synthetic plastics, mainly gotten from crude oil. So we have types of plastic. We have thermoplastics. We have also thermosets.